Hello, thank you for viewing this video. My name is Brian Alicia Morales. A little forward, my friend Edwin Martinez is going to be talking with you also. This is a project for the English class of Technical Communication about methane, its consequences, and possible solutions. As you see this video, you will find that I am not actually screen filming the screen because principally I took a screenshot to every slide, and afterwards I created an iMovie so I could upload the video faster to YouTube. So let's start with the information. Here we can see that we have some the introduction of what our video is about. We have the facts of how does it affect directly to the earth, the landfills, the cows. You can see a lot of some facts that will easily demonstrate us how does methane affects us. And also we are going to be explaining to you the possible solutions, so we will be successful in returning to our natural events for possible solutions. We'll be giving you a little conclusion of our project, and we're excited and by biography of where we get the information. First, before starting all the project, we must know what is it about methane. What is methane? It is important that you know what is methane, so you can know about what we are talking. I'm gonna read a little about what is methane. Methane is a colorless, odorless, and extremely flammable gas that can be explosive when mixed with air. This was said by Tuxdown in 2015. This flammable gas is highly contained in different parts of the world, contaminating the lands, animals, and ourselves. It is principally found on natural gas. Okay. This type of gas is principally produced in some areas of the world, so we can find it very frequently on natural gases and different areas that are principally our sources of daily life. So something that is easily founded in our daily life, how does it affect us? And not only affect us, but how does it affect the atmosphere? That is a very important question that we must answer. So, as I was saying, methane is affected our water and atmosphere systems that we have to know how. And I'm gonna read a little information about this. Due to human activities, our atmosphere methane levels have more than doubled in the last 200 years. That is a very big number. Methane is very effective at trapping heat in the atmosphere, and the heat is trapped. There is nowhere to go, and it becomes much hotter, which is also known as a greenhouse effect. And that is directly united with our next question, that is, what is the greenhouse effect? So now we go to another reading, a very, very, very interesting reading. It tells us what is about the greenhouse effect, and I'm gonna read this section. The greenhouse effect is caused when gases are trapped in the atmosphere by the sun's heat. The process occurs naturally, and it's credited with keeping the Earth's average temperature at 59 degrees Fahrenheit. Some scientists claim that man-made pollution, including carbon dioxide emissions from cars, mining operation, leaks from natural gas lines used for fertilizer containing nitrous oxide and burning of methane and coal has attended the natural process and accelerated, increasing the temperatures worldwide. So if we see the image that we have on the right side of the slide, we can see that a process, a circulatory process of what methane emission is causing. If we see the section above the C, above where it says C, methane emissions, we can see that because of the methane emissions, there is an increase of greenhouse warming and CO2 formation, and CO2 is dioxide carbon, and it accelerates the formation of CH4, that is methane. So, and afterwards, we can see that the increased warming of tundra surface and some ocean waters cause increase in methane emissions. That is a circle that is very common in the sea, and that is one of the examples that we can present on this work. And if we go a little further, we can see that there are some facts and information that we need to talk about. First of all, methane can be found in natural gas, as I was told before. That is a percentage that we can see. And carbon dioxide and some other areas, as I told you before. But we have to analyze this image as a very interesting matter of how it is presented of us. If we analyze the picture, we see a view of the ocean, the surface of the sea, of where we can go in a boat, we can go in a cruise, or whatever ambient we have an option, right? So if we go in the sea surface, you can imagine that the section and the part that is in darker blue is the ocean, the area of the ocean, and the seabed is the bottom of the sea. So if we analyze that image, we can see that how methane can be presented in the ocean. There are like a kind of tornadoes. If we see that kind of image, we can see a kind of tornadoes that are from the top of the ocean to the bottom of the ocean, in a kind of circulatory motion that are from the top of the ocean to the bottom, and they go all around the oceans, transcending all the water system around all the world. So that is a very big impact that we can see it presented in every kind of areas in the world, because basically our system is 75% water. So of that 75% of water, we have all this kind of called methane bubbles, and explained in the image, that are transcending and circling all around the world. So that is a very big problem that we can see, that methane is in 70% of the 75% of the ocean, in a very big sector. Afterwards, another fact, a very interesting fact that we have, is that, I'm going to read this section, the agriculture is responsible for 14% of our greenhouse gases production, with almost 23% of the attribute to methane. So, not only our kind of pollutions, our pollutants are the cause of the methane productions. Cows are a big part, as we can see in the second image, are a big contributor to the production of methane. But if we go a little farther, we can know that what we give as food, as any kind of alimentary source, that can be a product, that can be a matter of how these animals and how the agriculture is affected in the production of methane, because this is a change effect. If our water systems have methane because of the production in natural gases, and the underground water system has methane. The animals will have methane, and afterwards the methane is going to be directly affecting us in as humans, because we eat cows. So it is directly proportional of how the chain rules affects us in the production of methane. Two another very interesting facts are that the recovery of the ozone layer can be delayed to 10 to 20 years by the rising of the levels of methane and nitrous oxide. This is a very, very important fact, because not only it is affecting us as human, affecting the animals, affecting the ecosystems, affecting the landfills, it is also affecting the only protection that we have from the universe, the ozone layer. So this type of gas, the methane, is contributing on the slowing process of the recuperation of the ozone layer to almost 10 to 20 years. That is a very big number. Another detail that is very important, that methane contributes on the fast pace of the melting in the Arctics. That is basic chain rule, because if the temperature, as I told before, the temperature of the world is changing, and if our average temperature is 59 degrees and this gas contributes on the increase of the temperature, our systems that are the Arctics that need below average temperatures are going to rise, and directly affecting they will melt. And sadly, that is not only that they melt and we have an unbalanced system of water mixing salt water with melt of Arctic water. It is another problem is that we'll have an increase of the system of water and an impact of how much land our Earth is left with. So, with making a summary of the facts, it affects how water is distributed in the oceans, is affecting our animals and directly ourselves, the human race. It is affecting the ozone layer recovery process by 10 or 20 years, and it is affecting the levels of how the Arctic water is melting. So affecting our ocean system, how it's prepared. So it is basically a very sad process that we are living, but there are solutions. And now I'm gonna pass to my friend Edwin Martinez, who will give you more information on possible solutions for this problem.
Hello everybody, my name is Edwin Martinez, and we are going to be talking about the possible solutions for this problem. There are a few solutions to reduce methane emissions. One of them is the urea soil fertilizer. Urea is defined as a toxic organic compound found in biological wastes such as urine and sweat. Researchers studied and analyzed the effect of a fertilizer made with this compound on methane oxidation. Their study demonstrated that the urea fertilizer increased methane oxidation by provoking the growth and activity of the Methylobacter methylosarcina bacteria group. Another method is the mitigation of methane from animal production. Researchers studied and analyzed the most effective strategies to reduce methane emissions from ruminant animals. They concluded that increasing forage digestibility and digestible forage intake normally reduce methane emission. Also, there are other methane reduction options such as supplementation of lipids and concentrated feeds, feed processing, and some certain additives such as nitrate, ionophore, and tannins. However, The long term of these options are yet unknown, and some of these practices are toxic and are not economical. A third option is the anaerobic methane oxidation. Caldwell and a group of scientists studied the use of microbes to oxide the methane in marine, terrestrial, and subsurface environments, and this way reducing the input of methane and other greenhouse gases to the atmosphere. Unfortunately, there are still some doubt in the understanding of how these bacteria consume methane, but it doesn't eliminate the fact that this is another option to oxide methane using microbes. The United States Environmental Protection Agency, EPA, has a project called biogas recovery, which utilizes anaerobic digestion to produce biogas. Biogas is defined as a decomposed animal waste. Recollecting biogas helps to reduce greenhouse gas emission and also recover methane to use it as a cost-effective source of renewable energy for heating, transportation fuel, and even energy. As mentioned before, biogas is defined as decomposed animal waste. In order to obtain it, the process used is called anaerobic digestion. This natural process also reduces pathogens, odors, and waste. According to EPA, anaerobic digestion is the process in which, without oxygen, bacteria breaks down organic matter. The result will be biogas composed of mostly methane, which later will be processed to remove the non-methane components of the biogas and use the methane as a source of energy. Also, organic waste such as food, byproducts, oils, energy crops, and crops residues can be used to make biogas through co-digestions. This occurs when anaerobic digestion is used to break down several organic wastes in one single anaerobic digester. Now, this picture you see here explains the biogas recovery system. It first starts with the organic waste collection system, which collects waste in a way that is compatible with biogas recovery. Then it goes to organic waste handling system, which stores all this organic waste. Then to the anaerobic digester, which separate the non-methane compounds and methane. Then these co-products, the non-methane compounds, are used to create solid co-products or liquid co-products, such as fertilizer, flush water, concentrated fertilizer. And this methane, the methane, is used as electricity and heat, transportation fuel, or flare excess. Now, according to EPA, some of the benefits of biogas recovery are cleaner air and water by discharging pathogens, controlling odor, stabilizing organics, reducing greenhouse gas emissions, and providing opportunities for enhanced nutrient management. They also provide a source for distributed energy generation in rural areas, produce renewable energy to generate electricity and be used as a fuel for boilers or furnaces, yield pipeline quality gas or compressed natural gas that can be sold as a renewable fuel, provide a potential revenue source from the sale of energy, carbon credits, or co-products, improve relationships with neighbors due to reduced odor levels from manure storage and spreading, and generate products for use on the farm such as animal bedding and high-quality fertilizer. For more information regarding the biogas recovery, please visit the webpage epa.gov/oxstar. Now, another option to attenuate methane is the use of environmental factors. Researchers studied the possible environmental factors that could lead to the reduction of methane and hydrochlorofluorocarbons, HCFC. They found that the degradation of HCFC and methane oxidation are controlled by the same factor, with important parameters such as temperature, soil moisture, and oxygen and methane supply. Yet, this test may not represent a long-term study. In conclusion, by using methane oxidation methods in Puerto Rico to reduce the input of such green gas to the atmosphere will affect positively not only to the island but to the entire world, since no matter from where the emission of methane is, it affects the entire planet Earth's atmosphere. It is important to reduce the most methane emission possible to reduce the greenhouse effect. These are our references, and we would like to thank everyone for listening to us. If you have any question, doubt, concern, or comment, please do not hesitate to ask. Thank you.